Behind every great achievement, every triumph of human progress, you'll find people driven to move the world forward. People finding inspiration where it's least expected. People who lead with their imagination. But in an increasingly complex world, we face new challenges. And sometimes it feels like we've reached our limits. Now, with the help of intelligent technology, we can achieve more. We can access information that empowers us in new ways. We can see things that we didn't see before. And we can stay on top of what matters most. When we have the right tools and AI extends our capabilities, we can tap into even greater potential. Whether it's a life-changing innovation, being the hero for the day, making a difference in someone's future, or breaking down barriers to bring people closer together. Intelligent technology helps you to see more, do more, and be more. And when your ingenuity is amplified, you are unstoppable.
Please welcome Corporate Vice President, Artificial Intelligence and Research, Joseph Sirosh.
Good afternoon. How many of you use AI today? A show of hands? Oh, that's a good number of hands. And how many of you are data scientists? Okay, a small number. Let me tell you a story. On either side of me is a timeline of the Earth. It is 4.5 billion years long. And as you follow that timeline, I want to call attention to Earth's 4 billionth birthday. That is the beginning of the Cambrian acceleration. You know, before that, the vast amount of life on the planet were single-celled organisms, maybe a collection of a few cells. And then, in a short time period of 80 million years, the Cambrian period, all sophisticated multicellular animals and intelligent life on the planet appeared. And scientists have been asking why. One of the most interesting theories advanced is the emergence of vision, the ability to see at a distance. And when the eyesight and the ability to see at a distance emerged, here's what happened. Creatures diversified and multiplied in incredible complexity. Their nervous systems evolved. They were able to survive better. They were able to catch food and prey far better. And life exploded in diversity and sophistication in a very short time period. And they were able to explore every niche of the planet and survive much better. We are at a similar moment in software and technology with AI. We are at the beginning of an AI acceleration. Until now, computers and software were simple and stupid. They collected data and ran programs on it. Well, with the power of AI, you are now getting the ability to see into the data and act with foresight. And that is going to change how software works and how, in turn, we all live, work, and play. And powering this amazing upcoming revolution are three of the most fundamental trends in computing today. The cloud and the massive power available now in the cloud as a utility, and software and databases and data services delivered as a utility. That is the ocean in which artificial intelligence is going to be born. Data, the digitization of every type of behavior on this planet and converting that into digital data. Data is the oxygen for artificial intelligence. And then finally, artificial intelligence, advanced algorithms, they give you the ability to act with foresight upon that data, to understand the data and transform data into intelligent action. And when all three come together, software and perhaps even the economy itself is going to be transformed. Every type of software is going to be at the corner of that cube defined by these three axes, all in the cloud, all in with data, all in with AI, and every business is going to operate at that point as well. Let me start by giving you a few examples. Let me tell the story of Prism Skylabs. They are a company founded with a mission to bring intelligence to ordinary cameras all around us. Prism is expanding its reach to new industries and revolutionizing the way that businesses use video. Let's hear their story with the video.
The promise of AI has always been to make lives better and do things that we're doing now on our own in a much more efficient and much more powerful way. But to do that, AI needs to learn. And to learn, it needs information. And one of the best sources of information we have on the world and how it works is hidden in the video cameras all around us. A phenomenal amount of video is generated every year. And it's not just the hundreds of millions of cameras all around us, it's the billions of cell phones that we all keep in our pockets. Prism is a cloud software company that connects to cameras that already exist in the marketplace and analyzes that video in a way no human can. It slices and dices the video and puts that into our data structure so it's searchable and available to customers. Microsoft is a big part of the smarts that help the indexing and understanding of video happen. To use Prism, all you have to do is pull out your phone and type in what it is you're looking for and where, and Prism will find it. The value comes from unlocking the hidden information in video, and that can be just as valuable for a factory or a construction site or hospital as it is for a retail store. Prism also takes that video feed and turns it into a stream of information that can be used to let that business run better. Microsoft's computer vision API can understand different kinds of objects, texts, other types of information. Merchandisers might use us to look into their stores around the world, or people in retail operations might use us to build a dashboard of important metrics. Places like hospitals or healthcare facilities can use Prism to understand where their doctors are so they can more quickly connect those doctors with patients. In verticals like industrial or construction, Prism can be used to help track really important critical machinery. If you're on a construction site and you wanted to be notified when the cement mixer arrives, you can use AI to do that. Prism brings a really unique set of content into the world of AI and machine learning, and Microsoft brings some of the best technology and people in the world to help understand that content. It's an exciting time, and the coolest thing about it is we're just getting started.
Great. So, second example. If you attended Satya's keynote today, you probably heard about Epic. Epic is one of the largest healthcare software companies in the world. Over 200 million Americans have an electronic medical record in Epic system. So if you use mychart.com, you're using Epic software. And Epic is building, with electronic medical records data, on top of their software, a cognitive computing platform. It embeds machine learning across all of the workflows a hospital uses around Epic. Clinical insights, patient risk stratification, improved operations in the hospital, and for patient engagement. There's a cognitive computing platform that now hospitals can use to improve operations all across. Here are a couple of interesting examples. Pretty amazing ones, actually. Epic's data scientists found, by analyzing electronic medical records, that they could predict hypertension, high blood pressure, up to 2 years in advance. Imagine what that could do to improve lives of patients, the ability to foresee our future and help take preventive steps and perhaps live longer. A second example, they found that by analyzing the physician's workflow, they could simplify the workflow dramatically for common cases, such as for ear infections for your little child. And that simplifies the whole processing of that case, making both the patients and the doctors much happier and more efficient. And these are just the beginning, tip of the iceberg of what one could do with electronic medical records data to improve population health. Now, Prism, Skylabs, and Epic are just two examples of a vast number of organizations using AI. From the to Rolls-Royce applying AI for predictive maintenance of jet engines. AI is being applied all across to improve operations, to augment human capability, and create new business models. And as we engage with customers, here is what you're seeing. As they use AI to transform products, engage customers, optimize operations, and empower employees, they're actually building systems of intelligence. Systems of intelligence that take in data, apply AI, decide on the intelligent action to take, and then take the feedback and constantly improve. And here's what we learned from those interactions with customers. Systems of intelligence are actually hard to build and operate because it requires an end-to-end integration of not only hardware and infrastructure, but the flows of data, artificial intelligence, the specific actions that you drive, and then taking the feedback from it and constantly improving. Building reliable systems that operate 24/7, that do this flow, that's a new skill that needs to be built up, and it's not easy to do. So our customers want a strategic partner for their systems of intelligence to advise them on the architectures, and hopefully a partner who's done this extensively within their own organization so that they can take that knowledge and know-how and build these systems on their own. And then they want a well-engineered platform, very well integrated across all of these pieces, from getting data and processing the data to applying AI to deploying them and monitoring the workflows, instead of having to acquire 5 different pieces of software from n number of vendors and try to put them all together, which is very, very hard to do. And they don't want one-off consultant-built assembly of solutions. These things are what inform the platform Microsoft is building, the Microsoft AI platform. So let me tell you a little bit more about it. It is really cloud-powered AI for every developer. Has 3 major pieces: a collection of high-order services for AI, the infrastructure for AI that leverages everything in the cloud, and a collection of tools for making the AI development process much easier. So let's dive a little bit more into more detail. At the service level, we have the bot framework and the Azure bot service to help you build conversational AI applications. Chatbots makes it very easy to build them. Then we have cognitive services, which are pre-built AI capabilities. APIs hosted on the cloud that every developer, every one of you can integrate into applications without knowing how it is built. And then there is custom development. Azure Machine Learning for the most sophisticated of you to build custom AI applications with your own data and stand up your own web services at tier 1 scale and integrate that into workflows. That's a services piece. All of these services are built on the cutting-edge infrastructure of Azure. So in Scott's keynote today, you probably heard about Cosmos DB, a global multimodal database. Then you have SQL databases, which also, by the way, have now functions to embed machine learning deeply into the database. Then you have data lakes and SQL data warehouse, all of which form the data infrastructure. And then there is the distributed computing infrastructure of Azure itself. Spark clusters to do distributed training, data science virtual machines, Azure Batch to fire up massive number of VMs and do parallel training of AI workloads. And then capabilities like Kubernetes clusters in ACS and Azure IoT Edge. All of those form the AI infrastructure on top of which these services are layered and applications can be built. And then come the tools piece. We provide great coding and management tools from Visual Studio tools for AI, first being released today, which makes the development of deep neural networks dramatically easier, to Azure Machine Learning Studio, which has been the first serverless machine learning service, and it's been out in the GA for 3 years. Then Azure ML Workbench, which is new, which you will hear about more in the coming slides. All of those make coding and management very easy. And then we support on this platform all of the most popular deep learning frameworks and machine learning frameworks, such as Cognitive Toolkit, TensorFlow, Caffe and Caffe 2. All of these can be laid on the platform. So this platform is comprehensive, ready for the most sophisticated AI applications to be built. And now let me take Azure Machine Learning, one of the central pieces of the AI platform for custom building even the most sophisticated applications. So it's a productive, it's scale out, it's a full lifecycle AI development environment. And we are announcing today 3 major additions to Azure Machine Learning. First, we have a workbench that allows you to wrangle data, build models, deploy and manage them. A client interface makes it very easy to run machine learning workflows, runs on Windows, runs on Mac, it's cross-platform. And then there is experimentation service. The experimentation service runs in the cloud. It boosts productivity with the power of Spark, so you can run machine learning workflows ultra fast and just scale out. Allows you to harness the power of GPUs, GPU VMs. GPU VMs in Azure today come with up to 4 GPUs. And if you use Azure Batch, you can run as many GPU VMs as you're able to procure in parallel. And then model management service is the third one, which allows you to deploy, version, and manage and monitor models in production. So we allow you to put models in Docker containers. Those Docker containers can be managed very, very easily with the management service. Okay, so now let's talk about this as some more. I want you to think of Azure Machine Learning as an integration of 3 major capabilities. AI-powered data wrangling and program synthesis to make the data transformation part easy and minimize coding involved in data cleaning. An end-to-end machine learning developer productivity environment with the power of Spark, GPUs, and end-to-end lifecycle management. And third, the ability to deploy machine learning anywhere with the power of containers and deploy them on the IoT devices or on premises or even in other clouds. And so you bring all of that together, you have end-to-end tooling for AI development. That's what's exciting about it. So why? Let's talk about data wrangling. 80% of a data scientist's time is spent in janitorial work, cleaning data, preparing data. And I myself was a data scientist long ago, and it felt like the years I spent doing a PhD was all going to waste when I started actually doing data science. Well, that's what program synthesis allows you to simplify. You can have less cleaning and more exploring of the problem domain when program synthesis automates the data transformation steps for you. So here is how it works. A user expresses his intent in terms of examples. So there's a piece of before cleaning and data after cleaning. You show before and after, and you show a few examples of that, and then let program synthesis write the code for you in the middle. Many of you, by the way, are probably familiar with GUI synthesizers, right? So for graphical user interface writing, people actually are quite used to doing a GUI generator, and the code generates it for you. Now we are bringing code generation for data transformation in. So you express the intent, then there is a big search of all possible state of programs that can do that transformation. And then there is a machine learning algorithm and some other techniques are used to pick the best transformation program among all the candidate programs generated. And that program is then something you can take and execute on Spark or execute anywhere to wrangle all of your data and transform it from the input into the desired output. And that's program synthesis powered by AI. And this amazing capability, by the way, comes out of Microsoft Research. It's also, some of it's also available as an SDK that can be used for non-commercial purposes online. You will find it by search. And that amazing capability is inbuilt into the machine learning workbench. So the Azure ML workbench has that built-in AI-powered data wrangling. It also allows you to collaborate using notebooks and Git. And so a team can be highly productive and share code. It also has very important features of the software development lifecycle now being brought to machine learning development, which is things like version control and reproducibility, and metrics, lineage of the models, run history of all the experiments you have done, and management of all the artifacts that has been created in this process of experimentation. So it is really the ideal platform for tier 1 data science and AI development. So let's talk about some more of the features of Azure Machine Learning. So you have support in Azure Machine Learning for any machine learning framework or library. So we have taken an extremely open approach to this. There is tremendous amount of innovation that is happening in the open source world that our data scientists want to leverage. And we should, when we build a platform, we should embrace them and make it easy for our customers to use the tools they're familiar with. And so all of those tools that you see on the right are supported. We then support distributed learning with Apache Spark. Even deep neural network capabilities such as Cognitive Toolkit, CNTK, that's integrated with Apache Spark through an open source library we released called MML Spark. So you can actually do distributed training and scoring on a large Spark cluster of deep neural network models very easily. And then with the power of a service called Azure Batch AI, we are supporting scale-out GPU training. And you will see a powerful demo of that very soon. And then the third major feature, deployment. By the way, this is where a lot of data science efforts hit the rocks and fail. It is very hard often to take a developed AI model from the experimentation phase to production phase in a system of intelligence. And that's where the capabilities we have simplifies it. We allow you to Dockerize machine learning models, and you can deploy these Docker containers on Kubernetes clusters in Azure Container Service for scale-out deployment. You can deploy them in Spark on HD Insight. You can deploy them using Azure IoT Edge on IoT devices. You can have edge scoring. You can even take these Docker containers and run them on premises in any software, even take it out to competitors' clouds like AWS and GCP. That's incredible flexibility. So the best way to show you all this is with a demo. But before I dive in, let me show you a little bit of a roadmap of the demo. Mary Wall, my colleague, is going to be building a neural network model for aerial imagery. And she's going to use data wrangling to do some code-free transformations of file names and dates. Then she's going to do the machine learning training itself, a deep neural network, using Visual Studio Code tools for AI. And she's going to scale that training out up to 148 GPUs in Azure. So a single training job is running on 148 GPUs. And then she's going to take that model so trained and deploy them. She's going to Dockerize it and create a web service. It's an end-to-end application building that she's going to be able to show in about 8 minutes. That's the power that this platform has. So without further ado, let me invite Mary Wall to show you the demo. Thanks, Mary.
Sorry. here. Today, I'm excited to show you how Azure Machine Learning is helping the Chesapeake Conservancy, a nonprofit organization, monitor and preserve our natural resources. The Chesapeake Bay watershed, that I'm hoping to show in green on the backup VM. Okay, is it showing? Okay, sorry, is over 60,000 square miles in size. That's far too large to apply traditional record keeping to track deforestation and urban development. Instead, the Chesapeake Conservancy is using artificial intelligence to determine how every pixel of land in this region is being used. Together, we're constructing an AI model that can help them determine which regions are changing in land use over time. To go from raw images to a full-fledged AI application, we're using Azure Machine Learning. So this is the Azure Machine Learning Workbench. Sorry, folks. This is the Azure Machine Learning Workbench. It's a desktop application for Windows and Mac OS. It includes machine learning tools as well as Azure services, bundled with a GUI and command line support. So let's take a moment to just appreciate how beautiful and simple this workbench is. Because it's new, it's still clean and organized, but trust me, everything that we need to develop an AI model is in here. I'll start with data preparation, then I'll train my model and check how well it runs, and finally, I'll deploy it as a web service. Since this region is so large, we've divided the data along a grid into over 1,100 image files. Keeping track of each image according to its file name would be an incredible hassle. But fortunately, Azure Machine Learning Workbench includes some data preparation tools to help us with that task. So let me show you. My starting point is a file that lists all of the images in my training set. You can see that these file names contain some information on grid position. Letters indicate the row, and numbers indicate the column. I'd like to extract that information into my data set, and writing custom code to do that could probably take me a few minutes in Python. But fortunately, with Azure Machine Learning Workbench, I can do this just by providing an example of what I want. So this first sample is A4. I type that in and press enter. And as you can see, Azure Machine Learning instantly recognizes my pattern and fills in all of the other rows. That's very powerful. Let me show you a slightly more complicated example. Here, I'm going to reformat some dates. And deliberately, I'm going to choose the first one to be a little ambiguous. It's not clear whether the month or the day should come first in this date, so Azure Machine Learning isn't fully able to find my pattern. But in cases like this, it's easy for me to provide just a few more examples, and Azure Machine Learning Workbench will learn along the way and improve. Behind the scenes is an amazing technology that Joseph told you about, called program synthesis by example. You can see that along the right-hand side, all of the transformations I've done to my data set are being recorded. When I'm done, the workbench synthesizes a program for me to perform those same data preparation steps on new data. So if I decide to use a different image set for training, testing, and debugging, I don't have to redo any of this work in the GUI. I just use the program that's already written. When I'm done with my data preparation, I'm ready to train a deep neural network model to classify the pixels in my images. I could do that right here in the workbench using the built-in Jupyter Notebooks feature. But personally, I prefer to write my scripts in my favorite code editor, Visual Studio Code. Visual Studio Code is a free IDE for Windows, Linux, and Mac OS. And today, thanks to a brand new plugin called Visual Studio Code Tools for AI, it's even easier for me to use it to configure, to train my models. So I'm going to run this training script remotely on a data science virtual machine. So that I can make use of the GPU inside of it. I could also run this code locally or on a Spark cluster. When this run is completed, all of the output files, including the trained model, as well as my error messages, if I have any, will be returned to my own computer so that I can monitor how well it went. Once I'm convinced that my run has completed successfully and my code is working, I'm ready to scale up. I'll run this training code on an entire cluster of GPUs so that I can train faster. And using the Azure Batch AI service that's entering public preview soon, I can spin up hundreds of GPUs to do that training quickly, and then shut everything down. I pay only for the time that I actually use, which isn't so much because I've already debugged my code elsewhere. Let me show you my results. I've been tracking them using Workbench's Run History feature. Here you can see a summary of all of my completed runs. Using Azure Batch AI, I've run my training on clusters of up to 148 GPUs. That's over 700,000 cores. Before Batch AI, it took over 30 minutes to train this model for a single epoch, and I needed to run thousands. Now, each epoch takes 30 seconds. That's the power of the cloud to dramatically boost your productivity. Now that I have my trained model, it's easy for me to deploy it using the Azure command line interface. With a single command, I can package this model up into a Docker image and deploy it as a web service. Now, it's a simple cloud-hosted API that can be called from any application, anywhere, in real time. I've just shown you in a few short minutes how we're able to enable every developer to build their own custom AI models and incorporate them into their own applications. Thank you.
Thank you, Ben. Great demo. Thank you. So the maturity of a platform is really all about the applications that can be built on top of it. At Microsoft, we are using Azure Machine Learning in a number of internal applications. For example, Microsoft's finance organization. Microsoft Finance Organization is now able to bring in a wide variety of data sources to improve their forecasting ability. All of Microsoft's revenue and sales is now forecasted using Azure Machine Learning. And as Amy Hood says there in that quote, it's soon becoming an integral part of our financial planning and budgeting process. Very powerful. So now, let me tell you about another amazing integration. Today, there are 1.2 billion Office users in 140 countries and 107 languages around the world. Many of them use Excel as their primary data analysis tool, especially in finance departments. And now, for the first time, Excel users can seamlessly leverage the power of AI in the cloud by integrating Azure Machine Learning. Every organization can create Azure Machine Learning-based web services that can be invoked just like Excel functions. So you go into a column, and in a cell, you start typing Azure ML, equal to Azure ML, and you can see the collection of Azure ML functions that data scientists in your organization have created for you as the user. And these functions are just native to Excel. So just like other Excel functions, you can combine them, and you can have predictive columns being created in Excel. It's really infusing the whole power of AI. And by the way, not just for analyzing numerical data, but even images and potentially even audio and other kinds of unstructured data. It is whatever web service that's been created in the cloud and exposed to Excel as a function. Again, the power of this is amazing, and it can only be seen through a demo. And let me invite my colleague, Michael Saunders, who's a software engineer in the Excel team, to show you this power. Michael?
I want you to think about those satellite images that Mary explained a few minutes ago and the machine learning power to process those in the cloud. It's one thing to have an awesome ML model like that, but everything changes when you can share that model so it's accessible, right? You know, at everyone's fingertips. Now, I'm a huge fan of Excel. Show of hands here, who uses Excel most days at work? Okay, pretty good. And how many use Excel for fun at home, too? Oh, all right. It's good to see that I'm not alone there. I'm about to show you, for the first time, that Excel can have the power of AI in the cloud behind it. Every organization can create models that are customized to their needs to make AI really a natural, everyday part of any spreadsheet. Let me show you. Got to unlock here. So I've got a problem in Excel. I need to calculate the cost to maintain some paved roads. But all I have to work with is satellite images. So take a look at the spreadsheet. I have a bunch of rows. Each one is a location. It's got the image there along with the URL of that image underneath it in the cell. And if there was some way for me to measure the total surface area of those paved roads, then I'd be able to figure out the maintenance cost. All I need to do is type in a cell. Let me zoom in. Equals Azure ML. And immediately, as I type, I get a list of Excel functions. And those are all Azure ML services that data scientists at my company have created and deployed for me and my coworkers. And as an analyst, I don't need to worry about how those got there, the details of creating it, right? I can just pick the one that I need for my work. And that is classify land. And I can see right there when I selected it, it tells me it's going to figure out the breakdown by percentage of those different land types. So I'll go ahead and hit Tab. And now I can see Excel's asking me for the list of image URLs for those images that I want to analyze. So let's zoom out and select some image URLs. And then we're going to hit Enter. Here we go. So now Excel is sending those image URLs up to the cloud, and the Azure ML service is crunching those images. It's going to determine the percentages of water, forest, fields, and roads. Look at that. Right in the spreadsheet. Thank you. I've got the percentages of all the different types of land there with the roads. I have a chart in Excel showing that data nicely. And on the right-hand side, I even have some handy-dandy Excel math that calculated the maintenance cost for those roads. What I just showed you is, of course, only one little example of the unlimited number of Azure ML functions that you could create and expose in Excel, whether it's something like predictive analytics for finance or fraud detection, whatever you want. Azure ML Functions for Excel is going to be released in preview for you to try in a few months. And then it's going to be easier than it's ever been to really infuse AI into any spreadsheet. Thank you.
An amazing demo. How many of you think Excel infused with AI is a good idea? Imagine the power of every Office document, not just Excel, by the way, at some point in the future, being able to leverage the amazing power of AI hosted in the cloud. There's unlimited computing power behind the scenes. It's the power of AI, and the AI in the cloud will constantly improve. And that can be very, very revolutionary. It can really transform how we do our work. So now I want to move from custom AI to pre-built AI. Now, I personally believe a lot of AI should be like sort functions that we invoke in a piece of code. You don't really care about the actual algorithm and the way the exact sort function is coded. You just invoke the sort function, it sorts data for you. Well, a lot of AI can be simplified to that point. By the way, that's the history of computing itself, folks, which is we take extremely complex technologies, and then we engineer the hell out of it and make it simple and accessible to every programmer. And that's the path we are on with AI as well, so that we can have applications that understand us, that reason with us, that can process enormous amounts of data and turn it into actionable intelligence. So let me tell you about some of this. We now have on the cloud over 30 different APIs. APIs that cover everything from vision to speech to language to knowledge to search, and a few emerging ones, really interesting ones. So we've got cognitive services around vision to recognize emotions, faces, or things. We have services around speech to understand, translate, and reproduce human speech, text-to-speech synthesis. We have services around language to reduce the noise of human language into something we can actually act upon, and to understand emotion in text and other things. These are all APIs that you can integrate very easily into intelligent applications, just like every programmer uses traditional APIs in their coding. And now for the first time, we have added the ability to customize these APIs with your own data. And that's a unique capability that for now, none of our other cloud competitors are able to offer like we do. For example, with a custom speech service, what if we could set up a speech API configured with your language, with your domain, to recognize your accents, the accents that you care about? That is what a custom speech service allows you to do. And it makes it very, very powerful in specific environments where you have special purpose vocabulary and the users come from all over the world. Very powerful. And now let me tell you about the bot framework, which interfaces very well with cognitive services to build intelligent applications. So the Microsoft Bot Framework allows you to build intelligent chatbots. Now, there is a companion Azure Bot Service. The Azure Bot Service, which is in preview, it's an intelligent cloud-hosted bot service that scales on demand and comes with a lot of out-of-the-box templates for the most common types of applications, so you can get started extremely easily. Lots of our customers are leveraging these capabilities today. Here are two examples. Unilever, one of the world's large CPG companies, consumer product goods companies, has an HR bot. And they're looking to make HR service a lot more humanized than static intranet web pages. And so now they built a bot using the bot service and the language understanding intelligence service, which will answer questions about benefits and everything around HR intelligently. And they have well over 100,000 employees all over the world who are potentially able to use this capability. Publicis is one of the world's large advertising companies. They have taken cognitive services and built a very powerful app for intelligent recommendations of beauty products. So the application looks at the skin tone, looks at other facial features, looks at the context and time and geolocation and even the weather, and recommends you beauty products that will make you look your best. Lots of very creative applications are being built using the power of cognitive services and bots. And now I'd like to tell you about the use case of Stack Overflow. Now, how many of you here use Stack Overflow? Yeah, that's quite a few hands. Stack Overflow is one of the leading websites for developers. And they've been already using AI in a few places to empower developers. But now Microsoft and Stack Overflow are partnering to take AI to a whole new level to empower the discovery of the information that developers need as they actually program. So I'm actually honored to have with me David Fullerton, who's a CTO of Stack Overflow. David, would you join us and tell us why you're excited about AI?
Thank you. Thanks, Joseph. Really glad to be here. And excited to see how many of you are Stack Overflow users. As you may know, about 50 million people visit Stack Overflow every month to get answers to their technical questions. That includes tens of thousands of answers on AI and AI-related questions like natural language processing, deep learning, machine learning, as well as all of the Microsoft technologies you'll hear about today. What you might not know is that behind the scenes, we use AI in a few places to power those key experiences. Stack Overflow is about helping developers learn, share their knowledge, and build their career, whether that's on stackoverflow.com or as part of your own Stack Overflow enterprise community. So much of creating that experience for developers comes down to matching. We use machine learning to match developers who have questions with developers who are experts in that subject area so that you get the right answer to your question. We also use machine learning to match developers who are looking for their next job opportunity with the right company, so that whether you're a developer looking to build your career or a company looking to hire your next developer, you find the right fit. Of course, we're just getting started with AI. The field of AI is advancing at an unbelievable pace, which is why we're excited to see Microsoft releasing these tools for developers. We believe developers are writing the script for the future. And our goal is to help you move faster and get more done. We want you to spend less time searching for answers and more time writing code. So partnering together with Microsoft, we've created a demo using Microsoft Cognitive Services and Bot Framework of what that future experience might look like. So let me invite Ted Way from Microsoft up on stage to show that to you. Ted?
Thanks, David. It's amazing. Over 50 million developers go to Stack Overflow each month, making it the world's largest developer network. Stack Overflow and Microsoft are working together and empowering developers to build the future with AI. Today, I'll show you one way we're doing it. I'm here in VS Code as I'm learning Flask to build a website. And I want to learn more about doing routing in Flask. Of course, the first thing anyone would say is just go to Stack Overflow. But I'm afraid if I go off to Stack Overflow and browse stuff online, I end up in YouTube cat video land, and I may not come back. So instead, I'm going to ask the Stack Overflow bot. Stack Overflow bot is implemented as a VS Code extension. And here you can see that you can ask it some questions, it can parse a screenshot, write some code, even tell a joke. So I'm going to ask how to do advanced routing in Flask. You can see here in these results, on top are results from Bing Custom Search. With Bing Custom Search, you can customize a search experience and specify websites that you want to search in. So I'm getting answers only from Stack Overflow and not the entire internet. On the bottom are recommended tags that help me find more information. We took Stack Overflow's publicly available information and data, used Azure Machine Learning to build a recommendation engine, and deployed that as a web service with a REST API. So every time a query comes in, we call the REST API, and we get recommended tags back. So this is a very, very powerful way to incorporate machine learning into any application. So even though I'm getting answers to my questions, sometimes when I run my code is supposed to be perfect, but I get these error dialogues. Anybody else get these error dialogues when you're running your perfect code? Okay, so there are like 2 honest developers in the house tonight. What can I do about this? Let's see what the bot can do. I need help with an error dialogue. So it's asking me to upload a screenshot. So I'll do that now. And you can see that it's found key phrases. So what it's doing is optical character recognition, extracting the full text from this image, and then using the text analytics API to extract key phrases. So now I can just do a search based on these key phrases, selecting the second option here. And again, I get relevant, actionable results, and also tags to help me get more information. I don't have to copy the text from the error dialogue. I don't have to paste it into a browser. I don't have to do any more searching. This bot is doing all of that for me. So this bot is answering questions, helping me with error dialogues. Wonder if it can even help me with some code. Because I work on a diverse team, people speaking lots of languages. Data scientists speaking Python and R,
developers speaking C#, you name it. What I wanted to be able to do is to be able to talk in pseudocode because that's sometimes the easiest way to be able to communicate with everybody. So let me ask, can you write some code? So on the website I'm building, I have a list of names formatted as a first name and last name, and I want to reformat that as a different type of output. So for example, here's a first name, last name Joseph Sirosh, and I want it to be formatted as a last name and first initial. What's happening now is the bot is using the Microsoft Prose SDK, as Joseph and Mary just showed. Program synthesis by example. By giving it one example or multiple examples, it's synthesizing or generating lots of different programs and then figuring out what kind of program would fit the examples the best. So giving it this one example, let's see what the bot comes up with. All right, beautiful, sweet pseudocode. By taking what my example is, it's able to generate the pseudocode. And so you've seen how this bot is now able to answer questions, handle screenshots, even generate pseudocode using the power of Stack Overflow, the cognitive services, Azure Machine Learning, the Prose SDK. And this is how Stack Overflow and Microsoft are working together and empowering developers to build the future with AI. Thank you.
Thank you, David and Ted. Now I think I know why my fortune teller told me I'm going to have a bot-infused life. So bots are everywhere, making conversational interfaces dramatically more different. It's a natural interface. So now let's go back to the platform. You know, the strength of a platform, as I said, is really based on the solutions that are layered on top of it. We at Microsoft are making it ever easier for you to build these end-to-end solutions on top of the Azure Machine Learning and the cloud platform, and in some cases, really giving entire vertical solutions as well. So let me start with AI solution templates. These are solution templates to build end-to-end applications across industries and across industry functions. So we have AI solution templates for retail and commerce, healthcare, manufacturing, energy utilities, and more. And we have AI solution templates for industry horizontals, such as marketing, advertising, customer service, social media, and a lot more. These are all discoverable, by the way, from the App Source, Azure App Source, or the Cortana Intelligence Gallery. So you will see these templates these are actually live templates that you can instantiate and have a working sketch of a solution in your Azure account, live, in a few minutes. That's the power of it. And you can configure them, you can customize them, you can leverage partners to help you implement the entire solution. That's a great starting point. And these are some of the partners out of a long list who are helping us implement these solutions. From Cognizant to Blue Granite and Brilio, there's a worldwide group of partners who are now capable of standing up end-to-end systems of intelligence for you. So now let's take a specific solution. At Microsoft, we support customers in 191 countries and 46 different languages. That's actually not an easy task. We have interactions with over 70 million customers each year. And now, about 40 million of those interactions are chat interactions powered by AI. That's very powerful. It's great for customers when they can get their resolution instantly by talking to a chatbot. And by the way, the chatbot has to be good. If it is not good, if it's not solving a problem, especially when it comes to a situation like technology, like the things that we deal with, pretty sophisticated questions. And if you're not able to answer those well, then it's of course of no benefit. And we have found, in fact, after deploying this bot, we have been able to dramatically increase the number of cases that we are able to self-resolve for customers. And now we are actually super excited to bring this capability into the world for other customers. In partnership with companies like HP, we are testing and deploying them in customer care centers. And it is my belief that, honestly, after a few years, all of us customers, we will expect the power of such chatbots to be able to self-serve and resolve our issues without having to wait and endlessly sit on phones and suffer through the pains of customer support. And just like you've come to accept intelligent search results and online recommendations as part of your online experience, I suspect you will start expecting AI-infused conversations as a key customer support requirement. And again, the best way to see this for yourself is through a walkthrough. And let me invite Farah Sharif, who is a principal product manager in the Dynamics 365 AI Solutions Group, to show us how this can revolutionize customer care. Farah?
Hi, everyone. I'm excited to talk to you about how one of our first Dynamics 365 AI solutions is revolutionizing the area of customer support for your consumers, your support agents, and your support business leaders. Now, we've mastered this show of hands thing today, so let's do another one. Show of hands. How many of you get frustrated every time you have to call customer support? Exactly. It can be a rough experience. But the answers to all our support questions already exist somewhere, whether it's in the thousands of support documents, the FAQs, or in the millions of support interactions that already happen every year. AI helps extract knowledge from these scattered sources and builds a contextual understanding of your customers' support problems. Let's take a look at our solution's intelligent virtual agent, how it helps customers get their resolutions quickly. When you ask a question like, I can't sign in, search would show you a bunch of general results, like how to resolve your PC, Windows, or Skype sign-in. What we've built is a deep learning-based conversation engine that dynamically figures out when it needs to ask a clarifying question, like, hey, what product do you need help with? And then delivers the one accurate solution. And it doesn't do this just using static decision trees. It's actually intelligent and is learning and figuring these things out by watching past interactions. Let's take a look at the virtual agent we've recently deployed for HP. I have an HP Pavilion laptop here, and I'm going to ask the virtual agent about why it's being a bit slow today. It confirms my intent, and on the surface it looks like I just got an answer to try. But really what has happened here is the conversation engine has automatically skipped the troubleshooting steps that are not relevant for my problem. And notice here it didn't even have to ask me how much disk space I have or if I have malware problems, because it automatically checked for those issues on my machine using HP's device information APIs. And again, I didn't have to write a sequence of steps to tell the virtual agent to do all of this. No other virtual agent out there can do this today. And that's the kind of minimal effort support customers want. Isn't that cool? Even better, the virtual agent allows the user to jump directly to the suggested action with just one step. No more go to start, control panel, etc. Another pain point, gone. Now, let me walk you through how the AI is helping the support agents. We've built a smart assistant for support agents that provides them with AI suggestions to solve the customer's problem. It does this by looking at all of the support information in documents, articles, etc., and provides the next optimal step. Improving customer satisfaction, reducing case handle time, and improving agents' access to knowledge. And in the background, the beauty is that with the power of reinforcement learning, the engine continuously improves by watching how the agents are interacting with these AI suggestions. The agent assistant can integrate into any CRM solution. Here, HP is using Dynamics 365 for their customer service solution. Let me point out what the AI is doing here. So the agents can see probing questions used by other agents who've dealt with similar cases in the past. The system also searches across these knowledge sources and finds the most relevant solutions for the customer's problem and shows them to the agent. They can simply select the top suggestion and it gets experienced support agent is riding shotgun with all of your support staff. You got to look at how our solution improves the support experience for customers as well as support agents. For your support business leaders, the solution is complete with analytics that help you look into the data that the AI is using to learn, as well as it provides you with a conversation editor for the times that you need to go in and improve some of these conversations and rapidly respond to events like service outages or even new product launches. This was just a quick walkthrough of what our solution can do for your support business. We're very excited to be working with our external partners. Come check us out in our session on Wednesday morning and go to microsoft.com/AI to learn more. Thank you. Thanks, Joseph.
It's great. So AI at its core is also about allowing us to deal with the increasingly digital world around us and reason with all of that data. At Microsoft, we believe that AI can help transform the way society works to deal with some of our greatest challenges. For example, sustainably feeding growing populations, to ensure resilient water supplies, to stem the widespread and ongoing loss of biodiversity, and mitigate and adapt to changing climate. And this is why, with this promise of being able to tackle these incredibly important problems, that we announced a few months ago a program called AI for Earth. And now it's my pleasure to invite Lucas Joppa, the Chief Environmental Scientist of Microsoft, to tell us a little about AI for Earth and the magic of AI and the geographical information systems coming together to power this. Lucas? Thank you for joining us.
Thank you, Joseph. Thank you, Joseph. Okay, so the reason I'm here today is because as Microsoft's Chief Environmental Scientist, I'm definitely an AI guy. But I mean, when you're leading a program called AI for Earth, you kind of have to be, right? But most of the data sets that I deal with on a daily basis are inherently geospatial. And that means that I spend a lot of my time dealing with geographic information systems, or GIS, built by a company called Esri. And so as we began building up our AI for Earth program, it became quickly clear that converting raw geospatial data into actionable information becomes quickly difficult when the density of that data is growing as exponentially as it currently is today from geospatial systems like GPS tracking devices, IoT deployments, and this really rapidly growing constellation of high-resolution imaging platforms like satellites and drones. And so over the past year, we've been working with our partners at Esri on something that you can think of as GeoAI, integration of Microsoft's AI platform with Esri's GIS software to really empower organizations of all types to really get out ahead of this incredible growth curve in geospatial data. So to show you what I mean by that, I want to pick up where my colleague Mary left off, her demo training deep neural networks to classify high-resolution images, and show that we can actually run that model and execute that model from within Esri's GIS software. And so what you're looking at here is Esri's premium desktop environment, where you can manage, analyze, and visualize all types of geospatial data, as well as show multiple different data sources for an identical location side by side, like I've built here for a location in the Chesapeake Bay watershed. Now, I just want to walk you through what I'm showing here in these 4 views. So in the upper left-hand corner, we have the image that we want to classify. In the bottom right-hand corner, we have the results from Mary's model. Now, immediately next to that, I'm showing those same results, but this time as a mix of probabilities across all the classes that the model's trying to predict. And that's really helpful for me as a data scientist to be able to almost literally see inside how the model's thinking, where it's going wrong, and what I might be able to do to improve it. And then, of course, it's always helpful to be able to compare the results of your model with the data that it was originally trained on. And that's why in the upper right-hand panel here, I'm showing the land cover map provided by the Chesapeake Conservancy. Now, I think most of you will probably agree that these results look pretty good. But the real power of this approach is that you can actually use this same algorithm to classify land cover in places that it's never seen before. Like this location here in Oakland County, Michigan. And so as you can see from this empty panel in the top right, this is actually one of the many locations around the world where we simply don't have any data to train our algorithm on. But that's actually not really a problem anymore, because as you can see in these bottom panels, with just a click of a button, Esri's GIS software is able to immediately reach out and begin communicating with Microsoft's AI services, classifying that image in real time into categories like forests and fields, water, and impervious surfaces like roads and houses. Now, as you can see, our model still isn't perfect. Right? We still have a lot of training left to do before we're able to perfectly classify every feature in every location. But the reason that this integration between AI and GIS has already been such a game changer for us is because we suddenly become so much more efficient. So for instance, if we want to be able to compute a 1 meter resolution land cover map like the one that I'm showing here, but for the entire United States, that means that we'd have to crunch through something like on the order of 10 trillion pixels, all in one go. And so even with modern AI infrastructure, that might take a little bit of time. But instead, by using AI on demand like we're doing here, we can now compute just what we want, when, and where we want to compute it. And that really does free up organizations of all kinds to spend way less time on data wrangling and a whole lot more time on data insights and taking action. So there's just one more thing that I want to say here, which is that through some of these demos, we've been spending a lot of time talking about image classification. But Esri's world of GIS is much richer than that. In fact, it's filled with all sorts of structured data types that Microsoft's AI platform can help classify and make predictions about. And so now I'm really pleased to welcome Omar Mar, the lead for Esri's AI practice, to come and tell us just a little bit more about this emerging field of GeoAI. Welcome, Omar.
Thanks. Thank you. Hello, everyone. What if we can predict road accidents before they happen? What if we can optimize the ambulance car allocation based on these predictions to save more lives? Wouldn't that be fantastic? This is an example for what Microsoft AI, together with ArcGIS, can bring together to tap into the power of GeoAI. Let's demystify how this happens. First, we start by exploring spatial patterns in our data. We add data layers, like accident locations and road network layer, which is a data set of the road features, like number of lanes or maximum speed or direction. Notice the screen here. Many accidents are falling really very near to intersections. So we add proximity to intersections as a feature to our model. We use hotspot analysis to explore areas with statistically significant high or low values compared to their surroundings. And we use space-time cubes to navigate back and forth, exploring accident rates as they increase or decrease across space and time. Second, we look for, confirm, and fix spatial data anomalies. So please have another look to the screens. You'll notice many accidents are falling away from road links. We need to fix this. We use a technique called road snapping that comes within ArcGIS to associate these accidents to the nearest road link. What's really cool about this is when we start associating every single accident to specific road features, like double versus single lanes, the direction, the maximum speed, you name it. Adding temporal data features as well, like time of the day of the week, weekend versus weekday, rush hour versus not, etc. We call this spatial feature extraction, something ArcGIS is perfectly designed to do. What about the features that we'll be using in our model? We start experimenting with different feature selection techniques to see which subset of features will perfectly fit for our models. And then we start training our machine learning model to predict accidents. We use Azure Machine Learning for this because it comes with an amazing plethora of learning algorithms that we can train and experiment with to see which of these yields the highest prediction accuracy in a short amount of time, all in the cloud. Now, there's a question here. After some iterations, we end up deploying these algorithms into production. But do we stop here? The answer is no. Prediction is just a part of intelligence. Reasoning, taking decisions, and doing actions are equally important parts. ArcGIS can help facilitate this end-to-end cycle by facilitating geospatial actions and consuming the trained models as if they are plugins to take smart geospatial actions. In our case, it could be optimizing the ambulance allocation to reach faster to the areas where we predict high amount of accidents. At Esri, we are very excited to work closely with Microsoft to bring these capabilities to a broad range of industries and to empower every organization to tap into the power of Geo AI. Thank you.
The applications at the intersection of AI and geographical information systems are just amazing. It's a power to see with data. Remember, a satellite image or an aerial image is just a bunch of data, a bunch of bits. But it's only with AI now that you can see roads in that. You can classify land use. And then you go look at all of the data that's in a geographical information system that's actually structured data, like traffic patterns and roads. Then when you apply AI on top of it, what you can do is just simply amazing. So to enable this integration, we are today announcing a collaboration between Esri and Microsoft. We are starting with launching a data science virtual machine, which we call the Geo AI virtual machine on Azure, to help integrate AI and GIS development. So the virtual machine itself comes with all the popular tools for AI, tools like R and Python and editors and others, which are very common. And then it integrates with ArcGIS. So ArcGIS is from Esri. And so data scientists can now compose them and build very, very powerful applications. And using R and Python, they can access the data in these geographical information systems and deploy really powerful models combining both and really have Geo AI applications. So in conclusion, I want to make this point. It's not about if you're going to use AI, but when and how. Microsoft's AI platform is there for you when you decide to. It helps you build systems of intelligence with the power of the cloud on all types of data. You can do data transformations, data wrangling with big data, GPUs. You can use open source tools. You can deploy anywhere, on any cloud, on the IoT edge, even to Excel. You can build cognitive applications and conversational systems. You can integrate natural language processing and vision and speech and knowledge, all of these into applications and build intelligent conversational systems and bots. And you can develop and deploy AI solutions for common business scenarios and make a difference with AI for societal impact. And I want to conclude with a story. Now, eSmart Systems is a startup that's using the power of Azure and AI for the utility industry. They've built a connected drone that helps you inspect infrastructure. Let us see how their system of intelligence with the connected drone came in handy after the devastation of Hurricane Irma.
We got called down here by a utility company in Florida after Hurricane Irma, actually on our way from Hurricane Harvey down in Houston. So we drove over here and we are assessing the damage that Hurricane Irma caused on in the Florida area.
The client that we have here in Jacksonville is JEA, and so far everything's gone very well. It's interesting using cutting-edge technologies such as drones with cutting-edge technologies such as these mobile command centers that eSmart Systems brings to the table.
In conjunction with them, we are giving real-time live stream information back to basically anybody back at the utility.
Their data analytics are seamlessly integrated to the Microsoft cloud and are able to create actionable intelligence for the end users.
The biggest way it benefits the community is to basically bring power back as fast as we can. So if that eliminates a linesman climbing up to lines or anybody basically going into an area that's not safe, drones allow us access to areas without putting a human in harm's way.
The UAS use case is safety, and being able to have an eye in the sky in a place where you wouldn't be able to safely put a manned aircraft or you wouldn't be able to safely put a human on the ground to, say, inspect something in a traditional method.
As this is the safest way to give this post-damage assessment for the utility companies.
So being able to provide new types of data intelligence to an end user.
The data that we give to the company is all geolocated, so it's a very simple way for operators in the office to direct the linesmen of where they need to go fix and what parts they need, the crew that they need to get the power up as fast as possible. And this can all be done in real time.
It's great to be able to bring some sort of new type of relief to a disaster area such as where Hurricane Irma hit in Florida.
Technology empowers us all. Thank you very much. Enjoy the conference.